Okay. Now, positive predicted value and negative predictive value. Okay. So, those are next. So, positive predictive value and negative predictive value, and these come from the discovery rate. So, false discovery rate. Okay. So, now this is not filled out. So, this will be false discovery rate is probability of actual C sub 1 given we predict C sub 1. So, of all the C sub 1s that we predict, how many are actually C sub 1? So that will be that divided by that. No, sorry. Actual C sub, okay, so here false discovery rate, sorry, I made a mistake. Okay, so we predict C sub 1, but we discovered C sub 1 falsely. So that means the actual were actually C sub 2. So that is our false discovery rate. We discovered something to be C sub 1, but that's false. It's really actual is C sub 2. So that's our false discovery rate. So we're predicting C sub 1, okay, but actually it is that. Okay. Okay. And false omission rate is we omit, so that will be probability of given that we predict C sub 2, so which means we are omitting. We are not saying that that's a positive class, but actually it turns out that it is. So actual is C sub 1. So that would be false omission rate. Okay, I overwrote on it. False omission rate. So that would be, so we predict C sub 2, but actually turns out to be C sub 1. So it will be that. Okay. All right. So now these positive predictive value and negative predictive value are the true discovery rate. So it will be 1 minus these two. So which means given we predict C sub 1, they're actually C sub 1. Given we predict C sub 2, they're actually C sub 2. So that's what we have here. Negative predictive value, positive predictive value. Okay. So then we have prevalence. Prevalence is, now we are into the total data set. So of all the observations that we have, what is the rate of positive class? The rate of positive class is, okay, so the actual positive class is 12 out of a total of 24. Okay. And next is detection rate. Detection rate is, okay, how many are we detecting as owners? Okay. How many correct detections? So it's so there are 10 of them that are correctly detected as owners, okay, out of the total of 24. So that is our detection rate. What I can understand what you're saying.
You're saying owner, but the cells is under non-owner. So
Okay, did I make a mistake?
you're pulling the 10 from non-owner.
Okay, so detection rate, C sub 1 is non-owner. C sub 1 is non-owner. So our primary interest is in non-owner. So we are correctly predicting non-owners 10 times out of a total of 24. And that is the detection rate. Okay. And detection prevalence is how many are we detecting. Okay, so this is the actual detection rate. This is detection prevalence is how many are we detecting as positive class, which is non-owner, out of the total data set. Okay, so that's what you see here. Detection rate and detection prevalence. Now, balance accuracy, okay, it's a kind of sometimes the accuracy rate that we compute, in the regular way, diagonally add the two values diagonally, divide by the total, that's our accuracy rate. So that can sometimes be overstating the accuracy. So we have an alternative measure that is called balance accuracy, and that is the average of sensitivity and specificity. Sensitivity and specificity is from the from each class. So we are looking at each class and then looking at how well we are predicting. Okay, so take the average of sensitivity and specificity. Okay, so take sum these two and divide by 2. That is the balanced accuracy. Okay. Now in R, when you can access these individual measures, okay. So if you save it, if you save the confusion matrix, right? So let's say that we do it like this here. Okay, we'll put it in CM1. Okay, CM for confusion matrix. Okay, so now in CM1, if you see, so you have the so that it says what the positive measure is. The table here gives you the confusion matrix, and overall you have all the different measures. So so if you do by class, okay, so that's where you get all the measures that we just talked about. So if you say CM1, right, by class, all right, and then you say 1, so that will give you the sensitivity. And then say if you say 2, so that will give you the second one, which is specificity. Okay. So if you want to run several iterations of different methodologies and you want to collect a particular measure, you want to collect just the detection rate, so then you can build a vector of detection rates for different methods and different iterations by peeling it off of this list and putting it into a vector with a C. Okay. C will combine new values into the vector. Okay?